Hi, here I have components of a tiny high voltage generator. You can purchase the whole kit from eBay for less than €3 if you want. Now what do we have here? We have a transistor together with its heatsink. We have a resistor, a diode, a switch, some connectors, a PCB which circuit is printed on one side and the position of components is printed on the other side. And then we have a plastic strap to hold the transformer on top of this PCB, make it tight there. And then we have the transformer. Now the transformer has two primary windings and one secondary winding. Now these two primary windings together with these components, they form an oscillator, and that's basically make the primary side of this transformer. Now here I have a schematic of this circuit. As you can see here, so we supply the power from this side, and this is the main winding, this is the feedback winding of the transformer. Here's the high voltage side. We have a resistor, diode, and then the transistor itself. Now, as you can see, there are two paths for the current. So one path is here, basically comes from here to here, and one path is basically comes from here to here. Now, in another video, I'm going to make a simulation and analyze this circuit and show you how does this oscillator work. So as you can see, the primary winding of this transformer has a little bit thicker wire, while the feedback winding has thinner wire, because the feedback wire, we don't need to pass too much current through this winding, so that's why the wire is thinner. This one will take the most of the current, so the wire is thicker. Now, the high voltage side is made of a number of sections. This is basically to improve the isolation performance of the high voltage side. Now, for example, if each of the section can handle 2 kilovolts, let's say this is 2 kilovolt, 2 kilovolt, and so on. So the first section will get something between 0 to 2 kilovolt, and the last section will get something between 10 to 12 kilovolts. Now, because we have a large gap here, basically 1 centimeter gap, so this 10 kilovolt potential difference, it can hold it, so it does not spark on itself. So if the gap between these two external wires is small, so the spark will prefer to happen here rather than on this side. Now, obviously, if I increase the primary voltage and I increase the gap on these two wires, eventually the spark will happen on the winding itself and it will burn the winding. That one you want to avoid. If you would have made this winding as a layer type winding, basically starts from the beginning, goes up and comes back, goes up and comes back, eventually what would we have? The first layer would have voltage maybe between 0 to 1 kilowatt, and the last layer would have 10 to 12 kilovolts. And in that case, this 10 kilowatt potential difference would drop over very tiny thickness of the winding, and basically before the spark can happen over this area, it will happen through the winding and will burn the winding. So that's why the designer has made this one as a section type winding. Now what I'm going to do, I'm going to assemble this circuit, and then we will see whether it works or not, whether it produces some spark at this external terminal. And then I'm going to measure the primary voltage of this transformer and show you the waveform of the primary side. Okay, so now I'm going to assemble these components. All these components are very straightforward to connect. The only part that might be confusing is about transformer. So first thing you have to notice is to remove the enamel from these wires. That is what we have to do. And the second thing is that, of course, as I explained, the primary has two windings. One terminal of the thinner wire and one terminal of the thicker wire, they come together, and one terminal of the thinner wire and one terminal of the thicker wire comes again together. So what you have to do is you take one of the thinner wire and one of the thicker wire, so these two will go together, and this will form basically the midpoint of the transformer. And now this one will go to the feedback part, and this one will go to the main part. So this is what you have to do. This is the only confusing part. All the other one is very straightforward. So now I'm going to do that one. So for the transformer, we have to notice that so now I connected these two, but then this one I should have made it the opposite way. So this is not correct. So now I have to connect this side to here. For the transformer, you have to notice that the thinner wire, the one that is left, it has to be connected to this terminal, which is connected to the resistor from this side. Okay, so now the circuit is completed. I can actually pull this one to make it tighter. Okay, so the circuit is now completed. I have also connected this plastic strap to keep the transformer tight in place. Now I'm going to turn on my power supply and then set it at 4 volts. And then I'm going to turn on the switch. So the gap between this wire is maybe 2-3 millimeters. So the sound, you can hear the sound, but there's no spark. So maybe I set it a bit smaller. Nothing, maybe a bit more voltage. Yeah, then at nearly 4.5, then we have already the arc. Maybe I bring it closer to the camera. So we can see that, okay, I now keep this switch on. I turn on this switch and then gradually increase the voltage. So we can see that at around 3.5 volts, already the arc starts and then it disappears, 3.5, 4 volts. And the current that it draws is 1 to 2 amps. I don't want to turn this one on for a long time because the current is large, 2 amps. Okay, so the circuit works fine, and now I'm going to measure the input voltage of this winding. So I use my oscilloscope probe. Basically, I connect one side here and one side here. I set the probe at 10x, and we can see what is the waveform of the voltage here. Okay, so this is basically the voltage waveform. Now at 3 volts, approximately, we have this voltage waveform, and if I increase the voltage, this peak will increase. Now, as you can see, this scale is now 10 volts. So by approximately 3.4 volts gives me a peak of 34 volts. So there is a increase of 10 times. So when I explain this circuit to you, we can see that if I apply 3 volts from the power supply, the voltage on the primary side of the transformer will be already 30 volts. So the peak value will be 30 volts. Now, if here we have, let's say, 10 kilovolts, then the turn ratio of this transformer is something maybe 2 to 300. It's not that we directly convert 3 volts to 10 kilovolts. In that case, the turn ratio had to be 3000, but that is not the case. So this turn ratio is probably only 2 to 300. Maybe I will do another video to show you how to measure turn ratio, and then we do it for this transformer. Okay, so now if I increase the voltage a bit, such that the arc forms. So okay, so now we have the arc. Of course, there is a bit of disturbance, but then actually the voltage would drop also a little bit, but not much. And you can notice that the time scale here is 20 microseconds, and I have 2.5 time scale. So basically the gap between the pulses is approximately 50 microseconds, and we can see that the frequency is roughly 20 kilohertz. Now this particular waveform is due to the nature of this oscillator. So when I do the simulation in the next video, I will show you exactly why this type of waveform happens in this circuit. Okay, so that's it. Bye.